Okay, assignment 20B, number 4. Number 4, I think the first two problems are kind of okay, fair enough. Part C is a doozy. You're gonna see it on the back. You're probably gonna want to ignore it, which I would probably agree, but I'm gonna go through it anyway. I'll try to go through it fast, but it's a lot of work. But the first two are pretty fair. They give you functional values at 2, and then derivatives, first, second, third derivative at 2, and then just ask you to do a Taylor series about x equals 2. So since they've already done those derivatives for me, I don't have to do my little chart and do the derivatives, nothing. So it's just the function, which is -3, 5 times x minus 2, c is 2, remember? And this gets multiplied by x minus 2 squared over 2 factorial. And then that one gets multiplied by x minus 2 cubed over 3 factorial. Pretty straightforward, pretty nice. Pretty common Taylor. If I had to guess on a Taylor series, you'll probably see something like this, especially since they're saying you won't need your calculator, you can use it, but you won't need it, so there's probably not going to be a lot of computation. They probably wouldn't ask this question then, which is f of 1.5. Just plug in 1.5 to that, I got -4.958. Second part says the fourth derivative is always less than 3, and then use that approximation up there to show why f of -1.5 can never be -5. So the error in the approximation, that's the approximation, is the next term. So the next term would be the fourth derivative, whatever it is, times x minus 2 to the fourth over 4 factorial. But they told me the fourth derivative is no bigger than 3, so I'm just going to put 3 in there because that's the biggest the error can be. Times x minus 2 to the fourth over 4 factorial. I just plugged in that 3, put in the 1.5 for that, and I got 0.0078125. So I just took that error and I added it to that, or it's actually I subtracted it because I tried to get it close to -5. You see I did the -4.95. That error is absolute value, so I don't know which direction it's going. So just to make sure I went to the left because I'm trying to get to -5. So I subtracted the 0.0078125. I got -4.9658. So I didn't make it to -5. I'll never make it to -5 because remember that that's the closest I'm ever going to get because the next term is going to be positive. It's going to go back the other way. So I just can't get to -5 if I end up that way. So I think those two questions were pretty normal series problems. Part C is not. So you might, if you are actually watching this, you might want to just pause the video. I'm not going to talk you through the whole thing. I'm just going to show you what I did, and then you can kind of slow down to see it. But the question was, same information, they gave me this new function g, and they wanted me to write the fourth degree Taylor polynomial for g. They told me g was f of x squared plus 2. So I just went through the process. So remember the process is you start taking derivatives, right? So the derivative of f of x squared plus 2 is f prime of x squared plus 2. It's the chain rule. So times the derivative of what's inside, which is a 2x. That's the first derivative. And now the second derivative is the derivative of that. It's going to be a product rule. So it's the derivative of the first term, which is f double prime of x squared plus 2, times another 2x, but times the first term, so hence the 2x squared, plus the derivative of the second term, which is 2, times the first term, which is f prime of x squared plus 2. Not going to go through the third derivative, the fourth derivative. You can try to follow along with the work if you want. I just kept doing the same thing. It's more product rules. Got to be really careful with derivatives and chain rules and things like that. You can see how long and drawn out that fourth derivative got. Now, once I have my derivatives, so you might want to pause the video to see that. Once I have my derivatives, we're doing a Taylor series about 0, so I just got to plug 0 in, just like I normally would in the process. So I just plug 0 in. So g of 0 is f of 2, because that's at 0. So f of 2 is that -3, it's right there. Then g prime of 0 just means f of 2 times 0, because that x is 0, so it's a 0. Second derivative, I'll just do one more and you can see the other work. The second derivative at 0 is f prime of 0, f double prime of 2, sorry, f double prime of 2, which is that 5, times that 0, which is 0, plus 2 times f prime of 2, again, 0 plus 2, so f prime of 2 is that 5, 2 times 5 is 10. There's the 10. Third derivative, if you notice the third derivative has a x, an x, and an x in every term, so it's going to wind up being 0 because x is 0, right? Fourth derivative is going to give me another value, which is the 36. So then I wrote the series. It's the first term, which is -3, and then 0 times x, but that's gone. 10 times x squared over 2 factorial, plus another 0 gone, and then 36 x to the fourth over 4 factorial. So If you got that far, it's -3 plus 5x squared plus 3/2 x to the 4th. And then on top of that, they made you ask another question, which is pretty cruel at this point, because if you didn't get this, the rest is going to be hard. The next part's not that hard if you got that. The next one says, explain why there has to be a minimum. So I just took the derivative of this, pretty straightforward. Here's my function. The derivative is 10x plus 6x cubed. So 0 is a critical point. You could take the second derivative, or you could do the first derivative test. You could do the number line test. I just took the second derivative because it's really quick and easy. The second derivative is 10 plus 6x, or sorry, 10 plus 18x squared. Plug in the 0, I got 10. So the second derivative is 10, which means it's concave up, which means it's a minimum. I don't think I'd worry too much about that problem. It's pretty drawn out. Hopefully you won't see anything like that. Pretty time consuming, which goes against, I think, kind of what they might ask this year. And I promise I won't ask anything like that on my final either.